Before we dive into a real detailed investigation of the snowpack, I want to start by revisiting the basics, which is the ingredients of a slab avalanche. So, these are the components of a snowpack that must be present in order for a slab avalanche to occur. So, at the bottom of the snowpack, we have the bed surface, and on top of the bed surface is the weak layer. And then topping the bed surface and the weak layer is the slab. Now, the bed surface is a harder or more cohesive layer at the bottom of the snowpack on which the avalanche slides. And the weak layer is that layer of less cohesive snow that sits underneath the slab, and this is where failure and propagation occur. And the slab, which is essential for a slab avalanche, is a layer of more cohesive snow that sits on top of the weak layer and ultimately forms the avalanche. I think it's worth mentioning that the bed surface could simply be the earth, and when that's the case, then the entirety of the snowpack is sliding, which is called a full depth avalanche. Now, when we're using the language of more or less cohesive to describe snow, what we're really talking about is how well the individual grains within that snow are bonding with their neighbors. So, if snow feels firmer, it's probably more cohesive, and if it feels softer or more sugary, it's probably less cohesive. So, in this case, you can see this more cohesive layer of snow, which forms the slab, overlaying a less cohesive snow, which forms a weak layer. So now that we know the ingredients of a slab avalanche and we have a little bit of language under our belt, let's dive into some fun stuff and talk about how temperature variations within a single storm can form slab avalanches. So let's start with the earth, and let's say that a storm comes in cold. Now, I'm sure you guys have experienced that cold snow tends to be more sugary or less cohesive. So that cold storm is going to drop a layer of cohesionless snow. Now, if the temperature warms, that same storm could begin to drop more cohesive snow on top. Now, in this case, the earth is serving as the hard layer on which the avalanche slides, so it's the bed surface. And then that cold snow that came in early in the storm is providing the weak layer. And that more cohesive snow that was created by the warming of the storm is going to form the slab. When a storm comes in and starts cold, then finishes warm, we call this an upside down snowpack. So it has more cohesive snow over the top of less cohesive snow, and it is less stable as a result. Now let's imagine a scenario in which a storm doesn't produce a slab avalanche. So in this case, the storm comes in warm, so it drops a layer of more cohesive snow on the ground, and then it gradually cools. So in this case, the less cohesive snow is laid down on top of the more cohesive snow. In this circumstance, which is called a right side up snowpack, the only kind of avalanche you're really going to be concerned about is a dry, loose avalanche, or slough. So now that we've established some of the basics, we're going to spend the next few videos diving into a little bit more detail and thinking about the snowpack.